Hey everyone, thanks for joining us today. A big thank you to Daft for hosting this. This is great. Happy to see more and more community events and kind of seeing more people involved in the Iceberg space. Great, so, Iceberg Catalogs, great. Like Connor talked about it a bunch. This is fantastic. I want to talk about catalogs because they are essentially the gateway to your data. We'll get into that a little bit, but I'm curious if anyone can count how many times I'm going to say catalog throughout this talk. It's going to be all about catalogs, so just be ready. I'm Arsham Eslami. I'm a crazy founder. I'm visiting from Toronto. We're here for the Skydeck Accelerator. We have about 47 days left until our demo day, and we're going nuts. We're working on a SQL engine aggregator built on top of Iceberg. You bring your data to us. We give you the best query engine for your workloads. Again, why are catalogs so important? Why am I so passionate about catalogs? Why do I want to talk to you about catalogs today? I personally believe the file format wars are over. Seeing adoption from these industry giants like AWS, Snowflake, Databricks, is a great sign. I think we can kind of move away from that and start to focus on what to do next with the data and get actionable insights. But there's one more nemesis kind of in my in my thing. I'd love to know what you guys think about data catalogs. What is a data catalog? Does anyone have an answer? Catalog for data, cool. It's such an ambiguous term. Whenever I see this term online, I get such a crazy itch. Is it your schema registry? Is it your metadata store? Is it for your business context, for discovery? It's nuts. We got to work on something better. Throughout this talk, I'm mainly going to talk about Iceberg catalogs, the technical catalog, and whatnot. Okay, so why shouldn't you listen to me? Like I said earlier, I'm just some crazy founder. There's tons of them out there, so be aware of that. If you are not interested in the Iceberg ecosystem, there's probably no point in kind of listening to me today. If you love your current catalog and you're not looking for new tools or new technologies, no point in listening. Okay, so how did we get here? I want to walk through a little bit of the history of the big data space, kind of a little bit of what happened and kind of why we ended up here. Where does the catalog fit in and all that? Cool. Okay, so anyone seen this graph before and can maybe guess the axes? I'll start you off with the x-axis. It is actually years. What do you guys think is the y-axis that kind of tops out at 2 billion in 2010? You got a shy crowd. What was that? Phones. Oh, pretty close. This is actually, was there one more? Internet. Okay, very good. This is the number of active internet users over time. This is kind of what sparked the big data space. Companies started to deal with web scale data. As users start to grow from the 2000 era to when we started to get phones and social media started to produce user-generated content, the amount of internet users spiked, and also the amount of data that we were generating every day spiked massively. This is a 4x growth in just the users. What did this kind of cost? Before the 2000 era, we were all dealing with these kind of vertically scalable solutions like Oracle, MySQL. Your compute and storage was coupled together. If you wanted more performance out of your SQL engine, your query engine, because your data is growing, your only option was really to upsize your data set, or your compute cluster and whatever. Back then, there wasn't really an idea of compute clusters. Really, there was some sharding things that you could do and whatnot. But Teradata and these massively parallel processing systems came out, like Teradata, Netezza, Greenplum, and they were all about distributing the data to a bunch of different workers. They're all proprietary solutions, and they're very expensive. And then something really cool happened. It came out of Google. It was kind of like the secret sauce to their solution. Anyone know what that is at the very end, on the right? Average, okay, kind of. This is kind of like an algorithm. MapReduce, who said it? Good, very good. MapReduce. Great. So what MapReduce did is it allowed Google to kind of distribute their data across multiple different drives and hardware components, and then have MapReduce go and kind of shuffle the data and organize it in a way to kind of do more efficient operations on large scale data sets. These systems kind of worked at the time. This is kind of early 2000s still, but it was really complex. It was usually internally built by these bigger companies, and it wasn't really available. Then we kind of entered the Hadoop era. This was think of like mid 2006 to 2015, 2016. There's still tons of companies using Hadoop. But what did Hadoop do? It took like 3 core technologies of this kind of MapReduce space of the distributed storage, which is the Hadoop distributed file storage layer. MapReduce, they kind of reverse engineered the MapReduce algorithm, and then they had a resource orchestrator that would co-manage these kind of compute nodes and storage nodes and whatnot, and kind of manage the life cycle of everything you need to do to get data out of this data ecosystem. Yeah, it was huge. Awesome. Democratized it for everyone that wanted to do big data workloads, but there was no real way to write SQL. You couldn't really give MapReduce to your analyst, your business content analyst that knew SQL and say, oh, pull the data, generate your reports. It wasn't really possible until Hive a couple of years later. This was the first kind of like SQL engine on Hadoop, which kind of changed the game. Analysts now had access to tons and tons and tons of data. It did have some limitations though. It's, you know, when you're doing things through Hive, it's really just read-only. It's all read-only. It's only views and really high latency. So if you messed up your report, you're gonna have to wait a ton of time to kind of get the next one. In the early 2010s, we started to see some optimizations as more and more companies got involved in the space. We started to see the Avro file format. We started to see Parquet. Avro did, you know, schema evolution a lot better. You didn't have to break your whole Hadoop setup when you did schema migrations. And then Parquet did a better job for columnar lookup. So think of Avro as like the write engine. It was like, or the write format you want to use. It's really row-based, better serialization, better compression, really good for like write-heavy workloads. And then Parquet is for like the reads. Okay, there we go. So we are kind of entering the lakehouse era. Depending on who you talk to, we're already there. But you know, what is a lakehouse? A lakehouse combines kind of the best of a data warehouse and a data lake. All your data lives in object store, which is nice and cheap. You have your data stored in open table formats like Iceberg and Delta and Hudi. And then because of this open table format and because your data is actually on object storage, you can use whatever query engine you want now. You can figure out what query engine is best for your workload and apply that as you need it. So, kind of why? Why are companies adopting lakehouses? Obviously, everyone knows we're all in data here. Data gives a business the edge on their competition. Whoever has the most data can build a moat and all that. Lakehouses made it cheaper, so now you could do things with more and more data. It's more performant than a typical lakehouse, or as a data lake. And there's less vendor lock-in. A lot of these components are open source and able for you to move things around. Even for your object store, you can use things like MinIO, which is open source. All right. Oh, so this is a big one. So why do we need a catalog? We got our data, we got our query engines, we got our file formats. What really is the point of a catalog? You know, I've heard this analogy where, you know, your catalog, your data catalog, your Iceberg catalog is really like your taxi driver when you land from the airport, but it kind of tells you where to go, which is, you know, where you go is where your data lives and whatnot, but it doesn't really sit with me too well. I like to think of a data catalog as kind of like an airport. And I think of like the cargo as the data that gets moved around by planes, which are your query engines. The airport is the thing that facilitates, you know, where the people need to go, who should get on one plane, doing the security to make sure that the wrong people don't, you know, get involved and whatnot, or people don't get the wrong things. So what do catalogs do? They manage your files, They make sure they know like what's where and whatnot. They help you do some transaction management, and finally they do some things for query optimization as well. Nowadays with newer catalogs, we see lots and lots of new superpowers that they give to your query engines and whatnot when it comes to partitioning, compaction, and whatever. But it's an evolving space. Just the other day we saw new new tools and whatnot. DAF's coming out with cool stuff already. Like, this is already an outdated presentation. Great. Okay, so what are the different types of catalogs right now? There's service-based catalogs. These essentially store the metadata in a relational database. There's like a service that's constantly running, keeping track of things, and this is a centralized approach. Whenever you want to go access your data, you have to go to this service to ask it for different things through an API, and you get your data as you need. So Hive metadata store was kind of one of the first ones. By default, it runs in service mode, but it can run in different ways. But as soon as we saw this come up, multiple different companies saw like a scaling issue with the Hive metadata store. They started making their own private forks, and it kind of pulled away from like the open source like thesis that like Hive was built upon. Yeah, so it kind of takes us to the next type of catalog, which is file-based catalogs. This is a really cool concept. So in this case, instead of storing the data in a relational database service, the metadata actually is stored alongside the data itself. So no longer do you need like this like uptime that needs to be, you gotta have your SRE team manage and make sure that it doesn't go down or whatever. It's just in with your data. As long as your object store is up, you can query the data now. There are some challenges here because the different query engines are now responsible for kind of managing the data, but the advantage is you get this decentralized approach. It's very simple. Like I said, there's no real like external database dependencies or services you need to worry about. It's super resilient, which is really nice. One of the hard parts about this though is if you want to go in and do like a manual update or edit or whatever, you are now at the mercy of all these files that you've generated, and it's really difficult. Tuning this kind of system for performance is also challenging as well. You're kind of having to do a lot of analysis manually, which is tough. Brings us to today. REST catalogs are, I believe, the future on Iceberg. REST catalogs kind of give us the best of these two worlds. The metadata is still stored in files inside object store, but there's now a service that kind of sits on in front of it and centralizes things via an API. Why this is cool is like you can have really high concurrency with this solution, and the REST Iceberg spec is actually open sourced. That means that if there's something you don't want, like you can go and change this. You can go take one of the open source catalogs and do it your way. Cool. I'm going to walk through a couple of the popular original catalogs that have been around, and we'll talk about kind of the strengths that they have and whatnot. Okay, first, Tabular. Tabular was one of the first catalogs around, built by the creators of Iceberg, and it strictly follows the REST spec. I want to think of some analogies for kind of these different catalogs to kind of represent them in a more like human-friendly way, and I thought about screwdrivers. So we can think of Tabular as like your most typical classic screwdriver. Just a typical, flathead screwdriver, nothing fancy, no bells and whistles. By the way, I generated this with AI, and it was really challenging. AI does not know how to generate screwdrivers. You'll see it in the next one. This is actually one of the better looking ones that actually kind of looks like a screwdriver. Next is Glue. Glue was actually one of the earlier implementations of REST as well, built on top of Glue's like initial work on the metadata store that they have. Glue's biggest advantage, I feel like, is that you get like really easy integration with all the other services that AWS gives you. There's just so many tools available to you. It's unbelievable. Glue does so many things other than just being a data catalog. You can do things like automated ETL jobs. You can build crawlers out of it. You can do like elastic views, ML stuff. It's just unbelievable how many features they have under Glue. Actively, it's being improved. Like we saw Connor talk about how like Glue is now building in things with like the S3 table features and whatnot, and you got the weight of Amazon behind it, so you know it's going to be good. Yeah, Glue to me is one of these guys, you know, multi-purpose tool. It's a screwdriver as well, but you can do so many things with it. Yeah. Okay, so we got Nessie. So Nessie was one of the first-ish open source versions of an Iceberg REST catalog. One of the coolest thing about Nessie was how it has like this Git-like branching for your data. It gives you kind of like I guess the best way to say it is like you can change your data via like snapshots really easily in like a Git-like format. So easy to tag things. If you want like a developer branch of your data set, you can easily do it. Really nice. It's built by the early innovators in the space of Dremio. They've been working on this for a while, and we're gonna see this slowly get rolled into Polaris, built by Iceberg. Anyway, so Nessie, it's gonna be your quick exchange screwdriver. This is what I meant by it not being very good. The tips of screwdrivers is a terrible job. I don't know why I think screwdrivers are like this, but think of it as Nessie as like a quick change tool. You can quickly change to different versions of your data really fast. All right, let's talk about some of the new kids. I'm running a bit out of time. It seems like the trend with the new tools and the space, the catalog space, is really open source is kind of firsthand. We see tools like Polaris being built by contributions from Snowflake. They're doing a really good job. I think they're aiming to get their V1 done by Q2 of this year. It seems like, from what I've been reading, their security model is like a first-class citizen. They're doing lots of stuff on RBAC, fine-grained access control and whatnot. One of my favorite features, though, is that the nested namespaces. Having the ability to do nested namespaces is really cool. Not a big fan of the previous approaches. Yeah, this is your really high-scale, really fancy screwdriver. It's got a little blocking mechanism. You feel like a king using this. All right, next I got Gravitino. This is Apache open source as well. They have a really unique approach to catalogs. It's not your typical just, rest and go get it done. They're kind of thinking of things as like a broader scope. They want their catalog to be accessing lots of different things, not just Iceberg tables. This is like a catalog that can read from other catalogs, bring in table sources from everywhere. And also they're doing some things with the geo-distribution. I know you guys were interested in this. Like, it seems like this is a core concept for them that they want to tackle. So really cool. I think of them as like a socket set. You can fit whatever bit you want into them. Yeah. And finally, and there's lots of different, there's lots of different Iceberg catalogs, but I'm only highlighting a few. These are the ones that are fairly far along. I want to highlight Lakekeeper. I think the biggest thing with Lakekeeper is that it's super fast. Very light. It's not a big install. It's very easy to install, very fast, and it's Kubernetes native. So if you're deploying this yourself, they give you Helm files. They do all the things you need to kind of get it done. And they do have one interesting feature I actually want to bring up is they kind of have data contracts built in to the catalog. So you can define data contract right in the catalog itself. And if someone pushes something that's out of scope or the schema's changed or whatever, it'll actually reject that change for you without you having to, go around in loops and figure out what happened. Yeah, they're going to be the fastest way for you to, screw things in. Okay, cool. So I'm just about done for time. I want to talk a little bit about kind of where I want things to head, just given my nemesis of data catalogs and Iceberg catalogs and all this kind of stuff. We are slowly seeing this proliferation of like all these tools kind of coming together and consolidating on their feature sets and whatnot. This really gets me excited. I would love to have one tool where I can do all my governance, I can put my contracts there, I can access all my data from there, even if it's from other catalogs that some specific team uses. Data Hub, which is like one of the business-driven catalogs, just like last week released their Iceberg spec as well. So we're seeing people do their business context in the same place where they're pulling their data as well. This is fantastic. More of this, please. Would make me really happy. Yeah, that's about it. Thanks, everyone. Happy to answer any questions.
Thank you, Arsham. My first question is, how many times was the word catalogs said?
Oh.
Too many?
Ooh, yeah, too many, too many.
Okay, we'll take like 2 or 3, so I'll go in the back and then. 1 second.
Thanks, hey, thank you. That was really nice, very insightful. Can there be multiple catalogs pointing at your storage at the same time?
I think it depends. If you're using like a file-based catalog, you might end up getting some writes at the same time as the other one's writing, and you'll have some conflicts. I think it's recommended to have one catalog. If you're interested in having multiple different catalogs spread out throughout your use case for different workflows, I would highly recommend looking at Gravitino and how they do reading from other catalogs, so you can have one main catalog and then have multiple smaller catalogs on different subsets.
Gotcha. Thank you. Thanks a lot.
Thank you.
So I want to ask you why nest namespace is your favorite feature of the Polaris, and can you share any use case for that?
Yeah. So at Graybeam, what we do is we help people run their Snowflake workloads on other query engines, and part of that step is actually to move some of this data out into Iceberg. And I want to create an equivalent environment in Iceberg to Snowflake. You can't really do that with all the current, like I couldn't do it on Glue. That was a big pain point. And I'm like, now I have to nest the schema name in the table name and put some fancy delimiter in there. Just let me do normal namespaces.
Cool. Do we have one more? No? Yes? Well, okay.
How have you thought about migrating people off of Hive onto one of the more modern catalogs?
Well, Hive okay, I think it depends what your data is stored at. If it's stored as like Parquet, it's actually fairly, depending on your data volume size, to rewrite that as Iceberg and then plug in a different catalog right then and there. Mm-hmm. That's actually pretty doable. It's actually pretty built out. There's people doing it right now at scale. But if you have like sequence files, like Hadoop native files, it might be a little bit more challenging to get those out into like Avro or Parquet and then do the translation. But I think you need to start at the data level, move those over to something that's easier to integrate into Iceberg, and then go from there.
Thank you.